Hello, Pavilion in Egypt. Can we do a sound check, vice versa? I'm just recording this session on the Zoom for a backup because there's some internet issues in Egypt. You are on mute, but I can see you understand the message.
It's on. It's great. Well, thank you very much for joining in, and thank you very much for those people who join in from abroad. We are live casting this event here as well, and welcome to you outside as well. We are a little bit delayed because our keynote speaker got an important call that he had to take, but I think we will start anyway, and then we will invite him in during the session. We shall today discuss how to decarbonize the building stock by carbon requirement to buildings, and we will see different solutions for how to work with this. We have a good panel with Thomas Anker Christensen, Climate Ambassador to Denmark, who will give an introduction. And then we have Harpa Birgitsdottir, Professor on Sustainable Buildings at Bild University in Denmark, and Elisabeth Chage, Sustainable Energy for All and World Green Building Council Africa. And then we have Yoda Sevilla, Global Director of Sustainable Development by ARUP. And finally, we have Lone Pfeiffer with us, Director for Sustainable Building at Velux AES. She will be joining us on a Zoom link from Copenhagen. I will allow myself to start, even though that our keynote is not here, but we will fit him in. The reason for organizing this event here by the Danish Energy Agency, it is that we have set up some new requirements in Denmark to buildings. Those requirements I will explain shortly in a short minute. But before doing that, I would like to say that the basis of those requirements was in principle developed by the construction sector in Denmark. So the construction sector in Denmark moved together and made some proposals to the authorities on how could we move forward to decarbonize the building stock. It started up with what we call climate partnerships in Denmark. Denmark have taken the decision to reduce the carbon emissions with 70% by 2030. There are a number of challenges with this, but there are also many options with it, and the government asked the different sectors, altogether 14 sectors, to move together and try to identify what can we do individually in order to meet the 70% target that the Danish government have set up. The construction sector moved together, and it was the whole value chain in the construction sector that moved together, and they came out with a number of recommendations to the government. One of the recommendations was to set CO2 requirement to the building stock. Those recommendations was later reflected in a national strategy that the government came out with in April 2021, and that strategy was agreed upon, agreed between almost all political parties in Denmark. There was only 2 parties that did not participate in the agreement, so this is an agreement that has a very strong political support. They ended up with some very specific requirements to buildings in Denmark, and I will not go too much in details with those now because I can see our keynote is here. But what I would like to say is that we start with a requirement already 2 months from now, setting a requirement to all buildings above 1,000 square meter, and then we will increase those requirements over time. And when we come to 2029, we will have a requirement which is, from my perspective, very, very ambitious and what is needed to meet the climate change objectives. We will learn more about the levels of CO2 later on in the presentations today, but I would like to take the option to invite Thomas Anker to give a short and maybe a little bit deeper in some areas introduction to what Denmark is working with. Welcome to Thomas Anker, Climate Ambassador to Denmark.
Thank you very much, and sorry for being late. Indeed, maybe you could go back to that first slide about the 70%. Right. So good afternoon, ladies and gentlemen. Just a short preface to what I'm going to say. We had a national election in Denmark a week ago. Currently, we only have a caretaker government in Denmark. The Prime Minister has resigned, and hence we are in a situation of, I think in the UK they call it PERDA, the between an election and the formation of a government. So what I can mostly speak to is what we've done in the past, and not so much about what a future government will do, since that government is yet to be formed. But where we just started out is maybe also where I would want to start. The fact that 3.5 years ago a new Danish government came into office with a very strong popular mandate to reduce emissions significantly by 2030. The then electoral campaign debate was around whether the target should be 60%, which the governing party was campaigning on, or 70% as part of the opposition that eventually became the supporting coalition behind the government campaigned on. And in order to form the last government, a coalition came together around setting a target of 70% emissions reduction by 2030, and that ambition was embedded into first a political agreement, and then that was adopted in June of 2020. The first legal act that government did after passing the law was to do an energy efficiency in buildings policy. Before, we started looking at scaling up wind, looking at transport, the tax regime, or indeed what was the biggest theme in the electoral campaign we just had, which is putting a CO2 tax on agriculture. No, the first item that was discussed after the passing of the law 3.5 years ago was energy efficiency in buildings, and that says something about also the perception of energy efficiency in buildings as both being the most efficient way as a first step to reduce your emissions, but also as being one maybe the most low-hanging fruit in terms of having a return on investment. And I can assure the Danish Energy Agency every year for the government and for Parliament does a full modeling of all the options for the most cost-efficient pathway to 70% reduction. Every year we have to present in Parliament a plan that is costed of what we should do in the next fiscal year. And I think energy efficiency always pops up at the top of that list of recommendations. And you could think that it's a no-brainer. That's also why you are here, because you think that, hopefully. But unfortunately, it is not. There are many people who think that you need to look at the energy supply instead of reducing demand. Although reducing demand, I mean, all the energy we don't use is actually the biggest source of energy. In order to get on a net zero pathway as a planet, the IEA says that we should reduce energy use by 40% in the OECD alone. So, I mean, that is the biggest source of energy, is actually the saving of energy. And buildings is the most energy consuming sector. Now, in Denmark, in addition to the policy level, and I mentioned a number of different policies that the government has been working on, we've passed, I think, more than 70 different legal acts or actions over the last 3.5 years. The government also asked Danish industry to form climate partnerships in support of the government action. So, for each sector, 14 altogether of Danish industry, climate partnerships have been created, where each sector has set their own pathway towards 70%, including also looking at the cost and the most efficient policies. And indeed, there is a climate partnership for buildings and construction, where that sector is in the lead, jointly with their business association and the government. And we are encouraging other governments to look at that same way of organizing, because in a way it embeds the notion of public-private partnership into the DNA, the fabric of how you do both policy making and business. And indeed, in Denmark now, we are probably in a situation where the business community thinks that our level of ambition as a country is too low, and that we should go even further, even faster. I think both the Danish population thinks so, and the business side thinks so. So climate and climate action is one of the 3 or 4 items on the short list of the prime ministerial candidate from the Social Democratic Party, who has been asked by the Danish Queen to look into forming a government, and she's now consulting with all parties in parliament on what policies they would like to see, and hence climate and more climate action and climate ambition is on the political agenda in Denmark right now. Now, turning just for a brief concluding perspective to the global level, buildings and construction sectors combined are responsible for approximately 30% of global final energy consumption and 27% of total energy sector emissions. And that means that we dramatically need to lower the energy consumption in buildings. There are IEA figures saying that we need to increase 75%. No, wrong. That we need to decrease the energy consumed per square meter in buildings by 35% in 2030. That is with around a third over the next 8 years, in order to be on the net zero pathway. And that also is a huge economic opportunity. 2020, the investments into energy efficiency in buildings was around $180 billion. And we expect that figure only to go up. So if the private sector is ready to invest, governments have to do their part. Building codes is one area of policy making that is in focus. The number of countries with building codes has gone up from 60 to 81 over the last 5 years. And when I look at the European Union, where we do most of our regulation, the whole question of buildings, energy efficiency in buildings and renovation of buildings is really one of the key policy and investment areas where Europe is investing to get out of the COVID crisis, and indeed the crisis we're in now, also caused by the war in Ukraine. So to conclude, energy efficiency and energy efficiency in buildings is really one of those a bit hidden gems that should be much more in focus, because it's really where we can both make big strides toward 1.5 while also improving the building quality for our citizens, and indeed also make cost-efficient savings and a return on the investment that is really valuable for investors. So with that, thank you so much.
So now we will continue with a presentation by Harpa Birgitsdottir, who will present how we have worked with those issues in Denmark.
Thank you. So just to see if it is the other way. Thank you very much. I will quickly go through the data that we have collected in order to prepare for the requirements that are taking into force in Denmark in January, 2 months. I will focus on construction today. Of course, we are also in research working a lot on looking into how to work with existing buildings in decarbonization of the building sector. But now focusing on new construction. So in 2019 we got this project to gather data in order to have a data source, in order to have data for the how to set benchmarks and requirements in for carbon footprint of buildings for new construction. So, and it ended up in this study of 60 building cases that we had at that time, and I can tell you that we have much larger data sets available at the moment. So, just going quickly to the results of our studies. When we do a whole life carbon assessments of buildings over 50 years, new construction, different building types, so the main conclusions from our studies were that the whole life carbon, the carbon footprint of those buildings varied from about 6 kilograms CO2 per square meter per year to above 14. So the differences between the carbon footprint of the different building types and the different buildings were more than 2 times. And when we look at the materials, the embodied parts, buildings that have not been regulated yet, which is the thing that is going to be regulated from January, then the variation was about almost 3 times. And from the way we are calculating our whole life carbon assessment in the design phase, then we can also see that the materials are responsible for about 75% after the methods that we are using in Denmark. So we can see that there is potential here to reduce. Huge potential in total and huge potential in looking into the materials. So if you look at the requirements that we have in Denmark from 1st of January, where the limit value will be of 12 kilograms CO2 per square meter per year, then we can see from the figure of our 60 studies that, well, there are only few of the cases had that will not meet the limit value. But what we also, from this point of view that we are introducing a new discipline for the building sector, we have to see that, okay, it will be challenging for many within the building sector to learn how to do the whole life carbon assessment. But if we look at from the our climate urgency, then of course we know that this limit value is not that ambitious. But what we also have there is that we have a voluntary CO2 class of 8 kilograms CO2. And there we are hoping that so many actors within the building sector in Denmark will try to meet this limit value, because there we will be targeting that only few of our building cases were able to meet that target. And what we also know is also how will the limit value be, how it is expected to be in 2029. And just to conclude, what I showed you here was that this is the limit values that we have that are gathered from what we call a bottom-up approach. We are looking into how we are building our buildings today and how we might increasingly reduce the carbon footprint of our buildings. But what we also need to do is to look at this from the top-down approach, looking into what is our carbon budget and how large budget do we have for buildings, for new construction. And that we have also been looking into in Denmark in different projects. And I want just to conclude on one of this project is what we really need to focus on. If you see it, the blue path, that is where we are today and how we try to reduce from a bottom-up approach. But if we look into our carbon budget, if we are going to meet the Paris Agreement, then it is the green path that we have to follow. And what is our task now is to close this performance gap as quick as possible. So thank you.
Thank you to Harpa Birgitsdottir. We will take a round of questions afterwards, so we will not take questions now also because we are a little bit behind time schedule. So I would like to ask Elisabeth to take the stage and tell us about the situation in Africa.
Good afternoon. Thank you very much for joining us, and thank you for having me on this panel. Just to have it very quick to start off, Africa itself, on decarbonization, I'd like to paint a picture of Africa. So the land mass of Africa is 30.37 kilometers million square. That doesn't mean anything. It's numbers. But then if you paint a picture that you can fit the whole of USA into Africa, add China, add India, add Portugal, Spain, Belgium, Netherlands, France, Germany, Italy, Switzerland, and of course Denmark, and then fit UK in Madagascar. That's the picture of Africa. And I hope you take some time to read about the statistics on the wall about Africa. So the picture in Africa is that we're going to double our building. We are actually building our cities now. We're building our infrastructure now. So Africa provides a great opportunity to do things the right way from the beginning. We don't want to return to Africa in a few years and try to decarbonize existing buildings. Yes, we have existing cities, but we have opportunity to build right from the beginning. I'll talk about the population in Africa as well. We have 1.42 billion people. Great opportunity for the built environment to actually be part of the climate solution. If I bring in the policy aspect, that's another opportunity. We need regulations. Thank you. Please pass it. Sorry, we need regulations. We also need to build, when we're talking about decarbonization. Sorry, I'll grab the mic. Thank you very much. It's very pertinent that this message goes out, especially being in Africa. So when we talk about decarbonization of buildings and looking at Africa, we have to look at it holistically. I already said we have 1.42 billion people to consider. That is now. By 2050, definitely the numbers will go up. And part of the consideration of the global policy high-level working dimension is that we work towards the same goals. We don't have isolated silo efforts. Consideration is resilience in buildings. We know that Africa is suffering the most climatic effects. We're already in the climate crisis. It's not a matter of the future. We're going through it. Biodiversity. We already launched today the Africa Climate Market Initiative because we do see an opportunity there. And the built environment is one of the solutions that can be part of carbon trading. It mentioned biodiversity. There's water. Circularity, materials once again, creating an enabling environment that we can actually reuse materials. A lot of the building codes don't allow that. So there's a different paradigm shift that has to be addressed. Of course, human health. During COVID, we did learn that our buildings were our safe place. Equity and access, it's leaving no one behind. Everyone in Africa deserves to be in a net zero home. And of course, we come to carbon. But how do we do it with carbon? We need the roadmaps, building codes, minimum energy performance standards. And I was very encouraged by our keynote speaker, who actually said that the top recommendation they keep finding in Denmark is energy efficiency. And that's my core work, is to say, with SDG 7, we keep forgetting that there's 7.1 energy access. We know the numbers of people who don't have energy access in Africa. 7.2 renewable energy. Private sectors quickly went to renewable energy, but we forgot we have energy efficiency. It's the fast fuel. And it's the same case in Africa, and it's the same case in how we actually manufacture our materials. Some of the other aspects as well is incentives, innovative financial mechanisms. They have to work. We have to be innovative because they're not working for the built environment, and that's what we want to bring forward. So with all this, there's an opportunity to actually have energy transition plans, looking at how we're going to move forward. But it's not a theoretical exercise. We're talking about people who are already dying because of climatic effects. We need to act urgently. We have the numbers, we have the tools, and there's no reason why we shouldn't be doing that. So last but not least, we also have global principles from the World Green Building Council that will be issued in Q1 2023, and these help us to learn from each other. It's not a matter of one material is better than the other. We have to have a hybrid solution. We have to learn from the global north. We have to have skills transfer, and we need to work together. One of the other things as well is knowledge hubs. Right now, when we're sharing this information, it would be good to have it in a hub where everyone can access it. So already SE for All has a knowledge hub. It's actually online. You can access this. And I'd like to finalize on Africa just by something that was really excited this morning when our president from Kenya actually said that for Africa, we really have to, and especially Kenya, we have to comprehensively showcase the opportunities. It's not about the negative connotations, but we have green energy, the numbers are on the wall there, opportunity for that, smart agriculture, decarbonized manufacturing, e-mobility, and I do believe for the first time in this COP, green buildings was actually mentioned. So it means the built environment sector globally needs to focus on Africa, and there's already Africa Manifesto that has been launched on Friday. The Africa Manifesto brought over 700 million population represented by the green building councils to actually say these are the 5 key themes we want to prioritize on: energy, water, materials, finance, and infrastructure. Thank you very much.
Thank you to Elisabeth. It's amazing how big the potential is to reduce emissions from embedded carbon in materials. Now we're going to listen to Yoda Silvia, who will talk about how we do this in practice, I hope.
Thank you. We haven't got all the answers. We're just trying to get to the solution. I work, my name's Joda Silva. I'm the Global Sustainable Development Leader at Arup. Arup, for those of you who don't know, is a design, engineering, planning firm. We deliver buildings and infrastructure projects in about 140 countries globally. I myself have worked in Africa, not in Denmark, but the person who founded our firm came from Denmark, so we're in good company. We as a firm have got a net zero commitment, but we know that the biggest difference we can make is actually through the projects that we deliver. And so last year at COP, we made a commitment that we were going to address whole life carbon on all our buildings projects. And that's what I'm going to talk about today, if I can work out how to change the slides. Oh, wrong way. There we go. So we think that whole life carbon is fundamentally important. Investment decisions get made normally based on cost, in terms of capital cost and operational cost. We think that we've got to switch to a dual currency so that all investment decisions get made based on carbon and cost. And that carbon falls into operational carbon, which is very much about energy efficiency. But it's also, for the other part of the carbon is embodied carbon. And that's the carbon that's associated with manufacturing, making, and constructing buildings. But what this graph shows on the right is that that carbon isn't just all about upfront carbon at the beginning. When you've got to look at whole life carbon, you're looking at lifespans of 60, 70 or longer of buildings. It's actually things like building services and the facades that get replaced that can add up to as much as 1/3 of the embodied carbon in the building. Now, at the moment, embodied carbon is only responsible for somewhere around 25-30% of a building when you look at a whole life analysis. But once we get to decarbonized grids, that's going to change, because the operational energy is going to go right down, and it's going to go right down very fast. So the spotlight is going to get thrown onto the materials, the stuff that buildings are made of. So what we did is we made this commitment. We said we design buildings all around the world, and we can create a data set from the buildings that we design for our clients. And so that's what we did. We set out to create a platform. It's called Zero. It took us about 6 months to create. We've put a huge amount of investment into that. And what we were trying to create was a platform that could measure the whole life carbon for any building at any stage of the design process anywhere in the world. And we believe that matters. And that matters because there are tools out there that can measure the carbon at the end of a design project. You take the CAD model, the BIM model, and you pull down the material quantities and you put the carbon in. But actually what's needed is benchmark data at the beginning of a project so you can make better decisions at the outset. And that is the nut that we were trying to crack. What you can see from this diagram is that at the early stage of a project, and this data set is 954 buildings, it represents 600 million square feet, and it's data that comes from 30 countries around the world. So it's a very big data set. And what that showed us is a number of trends. And I'm just going to show you 3 slides that show you some of the things that we're learning from this data. So the first one is, at the beginning, we are pessimistic about the carbon potential of buildings at the brief stage because we're using historical data. Then the engineers come in and they come up with a much lower figure. But over the course of the design cycle, that's eroded. And it's eroded because at the beginning we don't measure everything. And so our message is you have to measure everything in a building. The structure, the facade, the building services, the fit out and the finishes. And then the other reason it goes up is because decision making through a project life cycle is based on cost. It's not based on carbon. So that goes back to my other message. We've got to get this dual currency into the decisions that we make. Sorry, I've gone the wrong way. This is another graph. The vertical axis is the carbon intensity per meter squared. So rather like Harper, we're looking at the carbon intensity per meter squared. We know intuitively that taller buildings are going to use more carbon, but we don't actually know what that means in practice. We don't have the information to benchmark it. So this graph enables you to benchmark your building and look at other buildings and say, are we in the right place? What's the carbon intensity of the outliers? Why are they much more expensive? And the ones that are performing really well, how can we learn from them and do better? And then also what our platform does is it spits out the information by discipline. Because one of the points that was made earlier by Thomas was the fact that this is actually asking people to do things differently. We've got a really fragmented industry. We've got lots and lots of different people in it. Lots and lots of disciplines get involved making a building. And we've got to empower each one of them to do their bit. And they're only going to do their bit if we can get to really granular data. And that's what these show for structural engineers, electrical engineers, etc., to encourage them to do things differently. Rather like the Danish government, the British government hasn't got there yet, but we are advising clients, particularly in Europe, who are trying to align their buildings based on whole life carbon against the 1.5 degree Paris-aligned trajectory. And so we're using whole life carbon to help our clients look at their buildings and make investment decisions about what energy efficiency savings they need to make in the short term and when they are going to need to do really big refurbishments in order to prevent their assets being stranded. And that is what is driving the market at the moment. And the final one is that this is a plus for us as an organization, because out of this, we've realized that our handprint, what the difference we make through the buildings we design, actually is 350 times bigger than our carbon footprint. So we know as an organization that where we need to put our effort is to improving a 1% improvement in what we do through the professional services we deliver can make a much bigger difference than worrying so much about flights to come to places like this. And that's why I'm here today, is to share that with you. The other thing is there's a bit of encouragement. The graph on the right shows that when we look at buildings and map them in terms of when they're due to be completed, we're seeing 40% reductions in operational energy. Now that is way short of the UN breakthrough target, but it's nonetheless encouraging, and that is a result of what's in legislation today. That's as a result of compliance today. So I applaud Denmark for going, leading the way and taking that philosophy of building standards and applying it to embodied energy, and actually putting this metric of carbon intensity per meter squared out there, because I firmly believe that that is the future. Thank you.
Thank you to Yoda Silva. It was a pleasure to see, and it was impressive how much impact you can have on the climate throughout your activities with clients. It's impressive. We will now move to a Zoom connection where we will invite Lone Pfeiffer to talk about how Velux have worked with decarbonizing buildings, or at least with one project on which we would like to share with you. Lone, are you with us? Yes, you are.
Yes, I'm here. I hope you can hear me.
You are very clear.
Great. Thank you very much for the invitation to talk, and thank you to the previous speakers for laying out the case so very clear, and making my presentation easy. As Kurt said, it was it's an example. It's a presentation of an example of what you have just talked about. It's a concrete example that we call living places, as an example of decarbonizing the building stock. Very happy to share a few slides on this and be able to indulge into discussions. This is Living Places, which is part of our sustainability strategy, where we focus on buildings and called Build for Life. So very suitable to talk about in combination with Build for Tomorrow. It's important for me to underline that this is a partner project, which the Velux Group has elaborated in strategic partnership with Effect Architects and Mo Engineers. And we want to transform spaces into favorite living places. And we want to focus on the planet and the people, and how buildings can be a connector between the outdoors, bringing the outdoors inside, and having the connection that we know very well after Corona lockdowns that is so important to us and our health. And we think that buildings are a key to obtaining this, not least due to the cases just presented. How we work this concept is to use a benchmark house, the reference house in Denmark, the typical size, building principle, foundation, size, and heating. And then we build up the living places, and here you can see it's a one-to-one and the reference that we use for living places. I will not go into the details. I'd rather show you these principles, because what we did was to say what is common today in the building industry. If you are attempting to build a one-family house, what is it we do different in terms of these 5 principles, which are the dimensions that we believe we have to work on. I'd like to focus on the healthy part. We see health as important for the planet and also for people. How did we enable this? The Professor Birgisdotter has already mentioned that we will have a cap of 12 for next year. Living places goes below 4. Sorry. And for the health, which I will not go into detail with in this presentation, but there we go from an indoor climate class 3 to 1, which is the best. We use, of course, the whole life carbon approach, life cycle assessment, and we use exactly the same method as will come into compliance in Danish building regulations from in 2 months. And this is the benchmark house compared to living places, where we improve with the 60%. A bit more about these numbers. We found that a lot of people had problems understanding life cycle assessment and the notion of whole life carbon. And it is, as you said just now, Joe, it's a new currency. Carbon is a cost. It's a cost to the planet. So what we thought was to put it up actually a bit like when you go shopping for a meal. You have a shopping list and you have availabilities in the supermarket for what it is you want to bring back. And you have a critical eye on a number of categories. It could be the meat or the vegetables or the proteins. So we put it up like that in the partnership and elaborated as to the choices, putting up here the benchmark house. How does that amount to 11.1 kilos CO2 equivalents per square meter per year? These are the choices, and what is weighing the most in terms of carbon. And then how did we, in which way do we do this different? And this is the timber frame house edition of Living Places, where we took a thorough look at the available materials, of course, the product-specific product declarations also, and assessing it according to the design and the function, and in particular the carbon. This is the carbon, this is the CLT, cross-laminated timber version, which is also somebody's favorite and a typical way of building light, and that is 3.9. The former timber frame is 3.8. And just so you have the overview, it's a one-family house built with timber frame, screw pile foundations, natural ventilation, heat pump, and it has just last week been third-party verified by the Building Institute at Aalborg University, and it results in 3.8 kilos, which in a prescription towards the future, which we also need to look at in what we call the carbon reduction roadmap, looking ahead, how much do we need to reduce? And the formerly described building classes looks like this. So we are future-proof. And putting it in a popular way, this is how we achieved it with no material or technology that is not on the shelves today. So there's nothing that has to be invented. Thank you very much for your time.
Thank you very much, Lone. I would ask the three panelists to go to the stage, and we have something like 10 minutes left. But before I ask here in the room, I would like to ask a question to you, Lone, while you are here with us. Have you had how have you worked with this project in the way that that you have worked with architects, engineers, contractors, and building material suppliers? How can you say anything about the value of working together like that?
Yes, I think it's important to underline that the process has been the key to achieving a different result. First of all, the carbon classes that we are looking towards in the building regulation in Denmark is very important, because that's the innovation highway which is known to the industry. So that is the first principle of aligning. What is the road ahead? Where are we going? The second one is to sit together and to work across the whole value chain, and to be able to pause and say, ask the question, what if? Because actually, we are a conservative industry, but we are able to do things differently if we are allowed. So you have to create that innovation space. And that is what enabled us to bring actually the lowest carbon footprint on a building project in Denmark.
And with that comment, I would like to ask you, Joda Silva, how have you worked with your clients, or how do you work with your clients in this sense? How do you get your clients to reduce the embedded CO2 in the constructions that they are buying?
Is it on? Maybe I just shout. Okay. That's not going to work. So what we're finding is that the situation is very different in different parts of the world. So the leading region is the European Union, because of the Climate Act and the EU taxonomy. Rather like Denmark, it's asking people who own buildings to start reducing the carbon in their buildings. And so literally over the last 12 months, it's been quite astonishing, the demand for services. And so I think what Denmark's doing is really important, because it's going to create the demand in the market. That's what we as designers need in order to talk to our clients. Where we can actually have most traction is to be able to look into a crystal ball and see those changes in policy and regulation, coming down the line. The reality is that most of our clients are motivated by risk. And once you turn the conversation not into an aspiration to save the world, but into you are going to have stranded assets. Your building is no one's going to want to rent it. No one's going to want to buy it off you in a future date, unless you improve the energy efficiency radically. And that's the big message that we're having to get home to our clients, is that this is not about incremental change, it's about transformational change. And none of us can do it. We're all trying to do it. We can't do it individually. We've got to join forces and work out how to do it better together.
Yeah, thank you very much. And Elisabeth, can you continue a little bit down the same path? How do you work with building owners in your regions?
Thank you. I think the trajectory we've had in the last 10 years has definitely turned around. I think first of all because of adaptation, living in the climate crisis. But the second thing, and where we saw the largest rise, was finance. Once the financiers asked that the buildings were green or were targeting certification or targeting zero carbon pathways, then the whole industry started changing. There was negotiations and collaborations with standards, with tools, and also skills development. So I do believe in the region, finance makes a huge difference. Thank you.
Yeah, we have one microphone, so... Well, Harpa, taking all those things into consideration that we have heard until now, what would you then say is needed for data to do those calculations that designers are doing on buildings?
Yeah, at least there's a huge need for good data on the materials in different countries. It's very important that we have like these national databases that we can work with, and also, of course, then also data from different material producers. But it's also a complicated exercise, so it's very important also for us to have good tools to work with it, because like Joe, as you showed, it's very important that you can also work with the life cycle assessment in the early process of the projects. So it's quite important that we are working on developing those tools. I can see a huge increase in tools just in Denmark at the moment, so I believe that this is going to be solved. And then the third thing is that we really need the data on different projects. Like you were saying, you are collecting on, in your case, we have been collecting in Denmark for about 200 building cases. So I think it's quite important that we work on this in order to get benchmarks, and can also to see the possibilities of how we can reduce and build up experience from the different projects across different countries.
Thank you. We have 5 minutes left, which gives each of the panelists 1 minute to give a wish. There's a question from the floor. We take the question from the floor instead.
Thank you very much. My English is not very good, but I tried my best to ask a question for every person of the panel. What I have understood, I think that if we want to reduce our print of carbon, I think that we have to have an holistic view from the conception to implementation. Because if we don't take care of each part of the conception, we are going to have a big carbon print. So what do you think you can help us to reduce our footprint or our handprint of carbon beginning of the conception of a building to the end of the building?
Thank you. I think I will let you answer the first.
It's the really important point. We've collected data, as I said, from about 950 buildings. They're all at different stages of the design process. And what we're finding is that we can take the detailed design data and use that data to create benchmark data that we would use really early on. So what people don't understand, they think there's one data set you need. In fact, you need data that you use at the beginning to make broad brush assumptions, and then you need much, much more detailed data at the end. But you're absolutely right, that needs to all join up. What we believe is that by collecting these big pools of data, and we're really keen to join hands with others like Harper and combine data sets, we can use machine learning to be able to analyze that data and to be able to create those estimates effectively at the beginning. I started my life as a structural engineer. It's a bit like doing reinforcement estimates. You know, at the beginning they're sort of reinforcement guesstimates, but they're well-founded guesstimates, you know, and then you get much more and more detailed. But you're absolutely right, and that's the missing bit at the moment, is being able to make good decisions at the beginning, because good decisions at the beginning don't cost you anything extra. And that's where we need to get it right.
And then I would like to call Lone in also, because I think you have also some experience, Lone, regarding the holistic approach to the design.
Yes, thank you very much, and well said, Joe, regarding the buildings. I think we need to realize that buildings are, to consider them as an organism. It's not something static. There is a tendency to consider it in frozen frames because it's easier for the sake of what you want to do here and now. So to decomplexify it, that often happens, but that is not the case, and we have to have the holistic approach and understand the building as a whole. And it is an organism in which we spend 90% of our time. So my best advice is, as much as we are critical consumers when we shop for food and what we will eat and drink, we should be critical carbon consumers at any stage of a building's life cycle, whether it's the one we live in or it's the one we work in or what we work with professionally.
Thank you, Lone. Elisabeth?
Thank you. I'd just like to highlight that this year the Kenya Green Building Society launched Green Buildings Materials Directory. So it's open source data. So once we talk about data, it has to be open source. And we find there's a lot of data out there, but you can access it. So this directory has details of the materials that help people to make decisions. And at the same time, it's designing for materials instead of designing, then seeking the materials. So look at the materials that are decarbonized anyway and design with that in mind, rather than designing then doing your bill of quantities and adding the materials and looking at costs, which is the current practice that is being used. And definitely, I like the presentation on mass timber, because it's a huge conversation in Africa that we're looking at commercializing forests so that we can use alternative materials in our building spectrum. Thank you.
Harper?
Yeah, what I think has been a really game changer in Denmark the past year or two is that we have had this understanding of the carbon footprint of the different buildings, and then we have the number to relate to, and we have done it like systematically, so we can compare within a different set of cases. I think that has been a game changer. Now people know, yes, they know this number, the 12 kilograms CO2 per square meter per year. Maybe it does not give any meaning in the UK or in Sweden or something, but it is a number that we are working with in Denmark. And we also, what is really good to see is that we have now number of building cases where they can really show that if you remember, I showed you that we will have a voluntary CO2 class of 8 kilograms, but Lone was just showing us some homes, some single-family buildings that are half of that, 4 kilograms CO2 per square meter per year. So I think it's a quite important game changer that we have those numbers to work with. But of course, the numbers have to give meaning and everything, but I think that really puts CO2 as a currency now, I hope, in Denmark.
Yeah, I think putting CO2 as a currency is really what it's all about. Those numbers just didn't exist a couple of years ago. I equate it to what I try to do all the time, which is worry about my weight. I want to reduce weight. I want everyone to reduce carbon in buildings, And the challenge is, it's not helpful if you're trying to lose weight to know how much calories is in 100 grams of cheese. What you want to know is how much calories is in that cheese sandwich. And that's the point Elizabeth is making, is we need to have building components that tell us how much carbon is in there. And these data sets that Harper's talking about, we just need to build up. And no one organization can do that. That's something that everyone has got to contribute their data to. And the work that I shared earlier, what I didn't mention, is that is information, that's data. Arup are very open to share what we've created with others if people are serious about joining hands and trying to move it to the next level. But it does need a combined effort.
Yeah, thank you very much for the last comment. Unfortunately, we don't have time for any more questions. We are requested to leave the room 3 minutes ago, but we took a little bit extra time because we started late. Thank you very much to the panel. Thank you very much to you, Lone, calling in from Copenhagen. It has been a pleasure to be here together with you, and I think you had made it very clear that CO2 becomes a currency. It is something that we need to measure buildings on in the future, and we need to have a level of CO2 calculations making it possible for us to benchmark buildings individually so we can see where and when we build good. So thank you very much to the panel, and thank you very much to the audience, also those who are listening in from outside. Thank you.
Thank you.